In question 10a, we have to find the integral of 1 upon 3x minus 2 to the power 3 upon 2 with the limits infinity and 1. So in the first step, we'll integrate it by bringing the expression in the numerator. So this will become 3x to the power minus 3 upon 2. First, integrating, we will get 3x minus 2 and we'll increase the power by 1. So minus 3 upon 2 plus 1 will become minus 1 upon 2. We will divide it by minus 1 upon 2 and also multiply it by the derivative of 3x minus 2, which is 3. So the final expression will become, so the 2 will go into the numerator. So we can write it as minus 2 upon 3 into 3x minus 2 to the power minus 1 upon 2. And this can also be written as minus 2 upon 3, and we can bring this in the denominator. So this will become square root of 3x minus 2. Now substituting the limits, which are basically infinity and 0. So when we substitute minus 2 upon 3 into 3 times infinity minus 2, and then we'll subtract it from, okay, so the limits were infinity and 1. And now when we substitute x equals to 1, so this will become minus 2 upon 3 into 3 into 1 minus 2. Now 3 times infinity will be infinity, and minus 2 divided by, so any number when we divide by infinity, that will become a 0, and this will become a plus. So 2 divided by 3 into square root of 3 minus 2, which is 1. So this will become 0 plus 2 upon 3. So the final answer will be positive 2 upon 3. In part B, the diagram shows the curve with the equation y equals to 1 upon 3x minus 2 to the power 3 upon 2. The shaded region is bounded by the curve, the x-axis, and the lines x1 and x2. The shaded region is rotated through 360 degrees about the x-axis. In part B, we have to find the volume of a revolution. Now, to find the volume, the formula to find volume is given by pi into y squared dx, and the limits, so in this case, the limits will be 2 and 1. Now, in the first step, we'll write it as 3x minus 2 to the power minus 3 upon 2, and we'll whole square the expression before integrating. So whole squaring the expression, that's 2 and 2 will cancel out. So the expression will be pi into 3x minus 2 to the power minus 3 with the limits 2 and 1. Integrating 3x minus 2 to the power minus 3, we will get 3x minus 2 minus 3 plus 2 will become a minus 2. We'll divide it by the new power and multiply it by 3. So the expression will become minus 1 upon 6, and this will be 3x minus 2 to the power 2. Now substituting the limits 2 and 1, and we can add the pi to the final answer. So we can leave pi as it is, and now we can just substitute the limits, which are 2 and 1. Now substituting x equals to 2, we'll get minus 1 upon 6 into, so 3 times 2 will be 6 minus 2, which is 4, whole squared minus, now we'll substitute the lower limit, which is 1. So this will become minus 1 upon 6 into 3 minus, so 3 into 1 will be 3, minus 2 will be 1. So 3 into 3 minus 2 is 1 square. So this will be 6. So simplifying this, we'll get minus 1 upon 6 times 16. So that will be minus 1 upon 96 plus 1 upon 6. Taking the LCM, so the LCM will be 96. So this will become minus 1. This is 16, and this will also multiply by 16. So this will become minus 1 plus 16. So the final answer will be 15 upon 96, and we'll add a pi to the final answer. Now we can divide this answer by 3 to simplify this. So 3 5 times and 3 32 times. We can write the final answer as 5 upon 32 pi for the volume of the shaded region. In part C, it says that the normal to the curve at the point 1, 1 crosses the y-axis at point A. We have to find the y-coordinate of A. Now, to find the y-coordinate of A, first we need to find the equation of the normal. And to find the equation of the normal, we need the gradient and a point. We already have a point. To find the gradient, we'll first find dy dx of the expression, which will give us the gradient of the tangent. So the expression was, so the equation was y equals to 1 upon 3x minus 2 to the power 3 upon 2. Now, before differentiating, we'll bring 3x minus 2 in the numerator. So this will become minus 3 upon 2. Differentiating this, we'll get dy dx equals to minus 3 upon 2. We will multiply with the coefficient. The power will decrease by 1. So minus 3 upon 2 minus 1 will become minus 5 upon 2. We'll multiply it by the derivative of 3x minus 2, which is 3. So simplifying this, we'll get minus 9 upon 2 into 3x minus 2 to the power minus 5 upon 2. So this is basically the dy dx represents the gradient of the tangent. Substituting x equals to 1 into this expression, we get minus 9 upon 2 into 3 into 1 minus 2 to the power minus 5 upon 2. So 3 minus 2 is 1. So 1 to the power anything will be 1. So the gradient will be minus 9 upon 2. And this will represent the gradient of the tangent, which means that the gradient of the normal will be positive 2 upon 9. Finally, forming the equation, we will get y minus y1 is equals to 2 upon 9 into x minus x1. To find the y coordinate of y, so the y coordinate of A, we know that A will have coordinates 0, comma y as it is crossing the y-axis. So the x value will be 0. Substituting x equals to 0 to this expression, we will get y minus 1 is equals to 2 upon 9 into 0 minus 1. Simplifying this, we'll get y equals to minus 2 upon 9 plus 1. And finally simplifying this, so taking the LCM, this will become minus 2 plus 9, which is 7. So the y coordinate for A will be positive 7 upon 9.